Tadi belah kanan. Alright, start.
No problem.
Okay. Hello and good evening. Today, we will present about the vibration testing on uniform cantilever, which is in subject EMM3528 mechanical vibration. Okay, first and foremost, I would like to bet good morning and good evening to our lecturer, Professor Dr. Wong Shavun. Okay, my name is Muhammad Ashraf bin Ahmad Shukri.
Hello. Hello, my name is Muhammad Arif Hakimi. My metric number is 193473. Farid.
Hi, my name is Muhammad Farid bin Wan Daud. Matrix number 192106.
Hi, my name is Ahmad Yuzi Hakimi bin Muhammad Yusof. My metric number is 192356. Hamzi.
Hi, my name is Hamzi Lokman. My metric number is 191973.
Okay, sorry, my name is Muhammad Ashraf bin Ahmad Shukri. My matrix number is 192216. Okay, now I will proceed to the introduction for this project. Okay, for the introduction, okay. For this as project, we usually talk about the uniform cantilever beam. So usually natural frequency, uniform cantilever beam is any number of concentrated mass, which is have several type of method, which is analytical and numerical combined method, ANC, general finite element method, FEM, transfer metric method, TMM. Okay. ANC method consists of the eigenvalue equation, which is first derived analytically by using the expansion theorem, and eigenvalue and eigenvector were calculated numerically. So the analytical and numerical combined method have the advantages among the others method. Firstly, the first advantage is no necessity to derive the property matrices of each beam element and then develop the overall one of the entire beam. So second, does not require tedious metric multiplication, so that the sum of computer time may be saved. So the last one is a uniform beam carrying any number of point masses of various magnitude and distribution along the beam line can easily solve, and no difficulty in taking more modes in the mode superposition equation, and hence higher mode natural frequency or better accuracy may be obtained. So these advantages is the strength for the ANC method compared to the FEM, TMM, ANC, and pure method. So we proceed to the problem statement. Okay, the problem that always happen during this project is during this project. Firstly, the condition of the cantilever beam always not in fixed condition and may cause the gripping at the end of the beam loose. So the second one, the problem that usually happen is forgot to give the initial disturbance. Okay, the third one, the cable of accelerometer is very sensitive. So the fourth one is initial displacement of the beam is bigger that can cause the problem in linearity assumption. And finally, beam is not fixed immediately, will cause the cantilever beam condition not in a good condition. Okay, I think that's all from me. Thank you. Now we will proceed to theoretical background.
All right, I will proceed to the theoretical background. So the theory of this experiment is the system is said to be under free vibration when a cantilever beam is given an excitation and left to vibrate on its own, where the frequency of the oscillation can be described as its natural frequency. And then the parameters which influence the value of the natural frequency are based only on the mass and stiffness of the beam. Some assumption can be made to approximate the real life model with a simple cantilever beam to simplify the calculation for the analysis of the cantilever beam. The, the important assumption are the mass of the beam, Islam at the free end of the beam. Other than that, the mass and stiffness of the beam is homogeneous throughout its body, and the vibration of the system is undamped. Okay, next. Next, please.
Sorry.
All right. Okay, this is the governing equation for this type of system. Okay, this the governing equation and the relationship between the stiffness of the system, the variable which depends on the length, the moment of inertia, and Young modulus, and the material of the beam and the cantilever beam can be written as follows. This equation. All right, next. Okay, this is the calculation for our experiment. This is the expected value, and to find the natural frequency of the cantilever beam. All right, that's all for the theoretical background.
Okay, for the project flowchart, basically, project flowchart is displayed by graphically the project objective and seek to more logically order the activities therein. But a flowchart can also help with monitoring process and event status reporting. So this is the flowchart. First, understanding the problem statement and objective of the project. Next, planning. Next, determining the different parameter for the experiment. Reviewing the related data and information for expected and experimental calculation. Preparing the progress report. Submitting the progress report. Collect required material and apparatus for the experiment. Conduct the experiment. Comparing the experimental and theoretical result. Preparing the final report, and finally is submitting final result. Okay, that's all.
Okay, thank you, Yuzi. Okay, next I will continue with the experimental flowchart. Okay, so firstly, like another experiment, we prepare the apparatus and material first, and then we will clamp the one of the end of the beam as a cantilever beam support. After we clamp this beam, then we will provide the initial condition for length and thickness for the beam, and then we will measure the vibration by placing the accelerometer at the opposite of the end of the beam, opposite with the support. And then we will open the software in the computer. We will state the initial deflection as an initial displacement at constant arbitrary position apart from the end of the beam. And then we will add a small tap at the end of the beam, and we will record the result that obtained from the accelerometer. And then we will repeat the step 5 to step 8 for 3 times to get the average result for our experiment. And then we will repeat the whole experiment by changing the condition of cantilever beam. And finally, we will measure and record all the data that we get. Thank you. That's all from me.
Okay, next for the experimental procedure. So firstly, we have to set up the apparatus and material such as figure that included in the report. And next, clamp one end of the beam as cantilever beam support. The initial length for the beam is 200 millimeter. Place an accelerometer with magnetic base at the end of the cantilever beam to measure the vibration, which is acceleration. Switch on the software to determine the vibration. An initial deflection given by initial displacement at constant arbitrary position apart from the end of the beam and allow it to oscillate by own. The free oscillation could also be started by giving small tap at the end of the beam. Record the data obtained from the accelerometer in the form of graph. Repeat the step 5 to 8 for 3 times to check the repeatability of the value and take the average. Repeat the whole experiment with different length of cantilever beam, which is 300 millimeter, 400 millimeter, 500 millimeter, and 600 millimeter. Record all the data in database. So that's all from us. Thank you for your time.
Thank you.
Okay, nice.
Start record.